An archerfish never leaves the water, yet it hunts insects in the air. By the end, you'll see how it solves a problem of bent light that fooled physicists for 2 centuries, in a fraction of a second. Here is the part you can watch for yourself. A silver fish the length of your hand hangs beneath the surface, aims up at a fly resting on a leaf, and fires a thin jet of water from its mouth. The jet hits the insect hard enough to knock it loose, and the fish darts over to swallow it before it drifts away. Fishermen across Southeast Asia described exactly this centuries ago, and for a long time that was the whole story, a fish that spits. But the spitting is the easy part. What the fish is doing in the instant before it fires took generations to pull apart, and the deepest layer of it still feels like it should not work. Watch closely, the trick is not the water. It is what the fish knows before the water ever leaves its mouth. Ask anyone what an archerfish does, and you get one clean sentence. It spits water to knock down insects. The archerfish, a handful of species in the genus Toxotes, lives where rivers meet the sea, in the brackish mangroves that run from India to northern Australia. Its food clusters on the leaves, stems, and roots hanging just above the waterline, out of reach of a fish that cannot climb and will not waste energy leaping into the open where birds wait. So it evolved a weapon made of water. It presses its tongue against a groove in the roof of its mouth to form a narrow barrel, then snaps its gill covers shut to drive a pulse of water through it. The result is a jet that can climb several feet into the air. Aquarium owners know it well. A captive archerfish will fire at a fly on the glass, a fingertip, even a bright light on the ceiling. Told this way, it is a tidy bit of natural engineering. A fish with a squirt gun, mashed to a habitat where lunch sits maddeningly out of reach. Stop there, and you have the version printed in most field guides. But that version quietly skips the hardest thing the fish has to do, and what happens by the end of this is the part no one expects. The trouble begins the moment the fish looks up. The trouble starts with the water itself. Watch a jet in slow motion, and it does not travel as a smooth stream. When the archerfish fires, it does something with its mouth that took high-speed cameras to catch. It opens the tip of the jet first and closes it last, so the water at the back leaves faster than the water at the front. In flight, the fast tail catches up to the slow head, and the whole jet gathers into a single heavy blob just before it reaches the target. This is the mechanism the old story misses. A thin trickle would arrive as a weak spray and do nothing. Instead, the fish shapes the timing so that all of its force lands in one concentrated slug at the last possible instant. Measured in the lab, that blob can strike with more than 6 times the power the fish's own mouth muscles could produce on their own. The archerfish is not just spitting, it is building a projectile in midair out of loose water. It even tunes the blob's size to its prey. A light gnat gets a gentle tap, a fat beetle gets a hammer. But shaping the water is only half of the puzzle, and it is the easier half. Because before any of this matters, the fish has to know where to point. And where the insect looks is not where the insect is. An archerfish sees its prey in the wrong place. So how does it hit? When light passes from air into water, it bends, and that bending shifts the image of anything above the surface. To a fish looking up, an insect appears to sit at a different spot and height than it truly does, and steeper angles lie more. This is the constraint that stumped people for generations. The fish must aim not at the insect it sees, but at where the insect really is. The archerfish beats the illusion by moving under its target until it is looking almost straight up, where light barely bends and the image barely lies. From there it aims at where the prey truly sits, not where the water shows it. A correction it drills into over a lifetime of missed shots as a juvenile. A young archerfish is a poor marksman, missing again and again, and the deadly accuracy of an adult is practiced, not inborn. Experiments back in the 1970s proved the fish genuinely compensates for the bent light rather than firing blindly at the image. The bending obeys a fixed number physicists call the refractive index, about 1.33 for water, and the fish behaves as if it already has that value built in. The physics that fooled human observers for 2 centuries is something this archerfish quietly solves before breakfast. And correcting for bent light is not even the strangest thing it does. The strangest part comes after the shot lands, in a sliver of time too short to think. The shot connects, and the insect is knocked loose. Now a new race begins, because a dislodged insect is fair game for every other fish in the pool, and the shooter has no special claim to its own meal. So the Archerfish does something that, for a long time, no one believed a fish could do. In the instant the prey comes free, the fish reads the very start of its fall, the direction it is thrown, how fast, from how high. And from those first fragments of motion, it computes exactly where the insect will hit the water. Then it launches, turning and accelerating toward that future landing spot, often before the insect has dropped more than a few inches. High-speed footage shows the fish commits to its heading in about 40 milliseconds, roughly 0.04 of a second, faster than you can register that anything has happened. It does not track the falling insect and chase it down. It predicts the endpoint from the opening frame of the fall and goes straight there, arriving just as the prey meets the surface. This is a genuine calculation of a falling body's path, the kind of problem we hand to students with pencils and equations. The fish does it in a reflex, with a brain smaller than a pea. And the ones that do it best are not simply born that way, which is the part that starts to unsettle the old picture entirely. An Archerfish can pick your face out of dozens of others. How? In a 2016 experiment, researchers showed captive Archerfish 2 human faces and rewarded them for spitting at one of them. The fish learned the target face, and then picked it out from as many as 44 new faces it had never seen, hitting the right one around 8 times in 10. Recognizing a specific human face is a task we file under advanced primate vision, something you supposedly need a large, folded cortex to do. The Archerfish has no neocortex whatsoever, and it did it anyway. That is the wider point the water gun hides. The hard computing this animal does, correcting bent light, predicting a fall, telling faces apart, runs on brain hardware we assumed was far too simple for any of it. For a century, big-brain mammals and birds set the bar for animal intelligence, and fish sat near the bottom of the ladder as twitchy, forgetful automatons. The Archerfish quietly dismantles that ladder. It suggests the machinery for genuinely hard problems can be packed into a small, ancient brain, and that we have been measuring minds by the size of the box instead of by what the box can do. The gun was never the interesting part. A hand-sized fish in a muddy creek has been solving problems in optics, ballistics, and prediction since long before anyone thought to watch, and it never needed to understand a single one of them to be right.